Hey guys, we're Glidemobile Incorporated, and today we're here to address the Hovercraft Challenge. I'm Dom.
I'm Amit.
I'm Ben.
And I'm Garrett.
Today we're going to be going through our various iterations of the Blade Master, our hovercraft.
But first, some history on the hovercraft.
The earliest designs of hovercrafts actually date back to the early 1700s. However, most of the major designs were made in the late 1800s and the early 1900s. And back then it was called air lubrication because it was the basic idea that the air that allowed the craft to hover was running underneath the craft and lubricating it and allowing it to have less friction. Progress really started for hovercrafts when smaller heat engines were developed in the early 1900s that were lighter weight and better suited for a hovercraft, as well as the Wright brothers' flight, because it brought back the idea of the ground effect, which was the idea that a craft that could fly in the air got better lift as it was closer to the surface that it was flying above. The inventor of the hovercraft was Christopher Cockerell, who was a British radio engineer, and he had a boat shop, and he wanted to reduce the friction on the boats that he was making. So he experimented with jets of air, and he realized that a perimeter design was the best. Small jets on the perimeter pointed towards the inside would help build the pressure underneath the craft necessary to create the hovering. And this beat out other designs because previous designs had air going directly down, and they didn't trap the air, allowing the pressure to build. The only advances that were really made after this were C.H. Latimer Needham with the rubber skirt that was put underneath the craft that helped it to take bumps better because the skirt could deflate and then reinflate as it went over the bumps. And really the only developments after those two major inventions were just better materials and engines used to make the hovercrafts, but the basic design has stayed the same.
Alright, in a hovercraft, there is a base, a fan that pushes it up, and a fan that pushes it forward, and the power supply for those fans. Our first base was made out of a styrofoam box, and it's really lightweight. But the fans we were going to use for it were 120 millimeters, and they were too big for this base. So, scrap this idea. Got a bigger base made out of a cardboard box. We attached one fan right on top of it to inflate the bag for it to hover, and we were going to use another fan right here to push it forward. But we realized that these fans are not strong enough with one 9-volt battery. So as you can see, if we attach it, little gentle breeze, not even an actual fan. So what we tried to do was take two 9-volts, put it in the circuit into one fan. It made it go faster, but it wasn't strong enough to either lift it or push it again. We tried 3 9-volts and we blew out the fan.
Our biggest problem with the first design was a lack of thrust, so to address that we employed an air mattress pump along with a smaller, lighter base. However, this introduced a new problem, which was balance. As you can see, the air mattress pump causes it to lean very heavily to one side. In this video, we chose to further develop the aqua design by installing a fan on the back to improve balance and provide thrust, like this. As you can see, despite the fan being on, it is not powerful enough to move the hovercraft.
Alright, the back fan is running. Just kind of sits there.
Alright, so as you see here, we have a couple of items on our table. This is the DC toy motor that we used in our foam models. Now, both of these models are prototypes. These are not final builds. And they are both made out of lightweight styrofoam, and this one used to have a skirt, but they're supposed to have a skirt on the bottom for lift. Now the DC motors would go in the middle here to provide lift, and then one here to provide forward momentum. Now this model here actually is second, after this model, we realized we wanted more streamlined version, so that's why this one has a boat shape at the front. And most of our models actually had forward momentum, but we had problems with lift, as you can see here.
Alright, it's powered up. It's moving really, really slowly. If you look at it from above, it will slowly go.
See, the toy motors were probably the most promising asset we could find, except we still needed more power in the end.
After realizing the computer fan is never going to work, we switched to some different options and eventually landed on toy motors. But with the toy motors, they probably could have worked, except for the fact that they were still a little bit too tiny, and we probably could have looked at some bigger, more powerful motors, as well as getting some better propellers.
All in the end, FEDD, we weren't as successful as we hoped to be. We got it to work a little, but not as much as we wanted to.